Okay, so let's look at what are the factors that determine how ions are discharged during electrolysis. So, number one factor that affects the discharge of ions during electrolysis is the position of the ion in the electrochemical series. The position of the ion. There are actually three factors. So this is number one factor, the position of the ion in the electrochemical series. The ion that you are dealing with, what is the position of that ion in the electrochemical series? That will determine whether it's going to be discharged or not. So in this, we'll be looking at the electrochemical series. So this is electrochemical series for cations. Remember, cations are positively charged ions. And this is that of anions. Anions are what? Negatively charged ions. So this is electrochemical series of cations. Please, you're expected as a student preparing for exams, you're expected to have this offhand. You're expected to have them offhand because the examiner is not going to give you this, but he's going to ask you questions like he's going to ask you questions under this topic. Are we together? Okay. Now, potassium is higher because it is decreasing electropositivity. So potassium is higher than sodium. Sodium is higher than magnesium. Magnesium is higher than aluminium. Aluminium is higher than zinc. Zinc is higher than iron. Iron is higher than tin, and so on. Are we together? So that is why, for example, when you want to do electroplating, you want to use another element to cover iron. Look at iron here. If you use tin, iron is greater than tin. If you use tin to cover iron, after some time it will rust. The iron will begin to rust. Why? Because the iron is greater than tin in the electrochemical series. But if you use zinc to coat this iron, it will not rust because zinc is greater than iron in the electrochemical series. Now, in electrochemical series, the one that is higher for that of cation, the one that is higher in the electrochemical series usually serves as the anode, while the one that is less usually serves like as the cathode. For example, if you have zinc and copper, zinc is higher than copper. Therefore, zinc will serve as the anode. The more electropositive will serve as the anode, while the less electropositive will serve as the cathode. But we'll talk about that when we discuss the standard electrode potential. So make sure you watch that video after this. Okay, now we are looking at position of the ions. How does it affect? So usually during electrolysis, if you have a combination of, say, if you have an ion like potassium and zinc, which one is going to be discharged? For which one is going to be discharged? Zinc is going to be discharged. The less electropositive a cation, the more tendency for it to be discharged. The less electropositive of a cation, the more tendency for it to discharge. The less electropositive, or even the same thing is applicable to electronegative. The less electropositive or electronegative, the more tendency to discharge. To discharge at the cathode. Are we together? You remember the drawing I gave us from anode to cathode? Okay, so that is to say, if you have a mixture of magnesium and zinc, which one is going to be discharged? Zinc. If you have a mixture of zinc and hydrogen, which one is going to be discharged? Hydrogen. Are we together? The same thing is applicable here. If you have fluorine and hydroxide, which one is going to be discharged? Hydroxide. If you have chlorine and iodine, which one is going to be discharged? Iodine. However, there are other factors that still determine this. The next factor that determines this is the concentration. Now let me give you some examples on this one. Let's say you want to conduct electricity. You want to conduct electrolysis of acidified water. Acidified water. What is acidified water? Acidified water is tetrodosulfaces water. In other words, water that you added few drops of tetrodosulfaces. We refer to it as what? Acidified water. Now let's look at this now. So remember, it is in water. So for this at the anode. So let's look at how the ions are discharged. The ions are discharged hydrogen plus tetrodosulfaces and then water, because remember, electrolytes, it must happen, electricity must take place in a solution medium. So water hydroxide. So between this and this now, which one will be discharged? As you can see, both of them are the same. This is positive. So the positive is going to be discharged at where? At the anode, at the cathode. The positive is going to be discharged at the cathode. At the cathode, one of the hydrogen is going to be discharged. So you have hydrogen plus hydrogen, and that will give us what? Hydrogen gas discharged at where? Cathode. Then look at these two. Which one is higher? Between these two, which one is the less electronegative? The less electronegative is this. Looking at the series, this is higher than this. So this person is going to be discharged. So you have at the anode, remember, at the cathode, positive is going to go to the negative cathode, and negative is going to go to the positive anode. So this person is going to be discharged at the anode. So at the anode, you have what? OH plus OH. That will give us what? Water plus O. Are we together? Water plus O. So this O is going to be O plus O. That will give us what? Oxygen. So at the anode, oxygen is going to be deposited, while at the cathode, hydrogen is going to be deposited. So at the end of the day, one of these is gone, and this one of this is, and this one is gone. So what is remaining? What will be the resulting mixture remaining? The resulting mixture will be what? You have hydrogen here, you have tetrodosulfaces. So the effect of the resulting mixture will be acidic, because there is an hydrogen ion here, and this reacting with this will give us what? Tetrodosulfaces. So the resulting mixture will be what? Tetrodosulfaces, which is what? Acidic in nature. So the examiner can ask you, what will be the color of the resulting mixture with litmus? So when you put blue litmus paper in acidic medium, it will turn from blue to red. Can you see this thing is very simple? Let's look at another example. Okay, so let's look at concentrated sodium chloride. Concentrated sodium chloride electrolysis. Electrolysis of concentrated sodium chloride. Which one is going to be discharged? Using the position of the ions in the electrochemical series. So let's disassociate the ions. What will it be? Sodium plus chlorine. Then remember, electrolysis must take place in a solution, and that will be hydrogen plus OH. Are we together? So between this and this, who is going to be discharged? This person is stronger than this person, or this person is more electropositive than this person. Looking at the electrochemical series, so this person is going to be discharged. And this is positive. So positive, where do they go to? They go to the negative electrode, which is what? Cathode. So at the cathode, hydrogen is going. At the cathode, you have hydrogen plus hydrogen. That will give us what? Hydrogen gas. Are we together? Then let's look at these two. Now, in these two, which one is going to be going? Naturally, if you come here, chlorine is higher than OH. So, naturally, chlorine, OH is going to go. But it will not happen in this case. Why? Because this is concentrated. Are we together? sometimes the electrode can even affect. This is concentrated. This is, had it been that this was dilute sodium chloride, if it was dilute sodium chloride, OH will go. But this is concentrated, so OH will not go because there is higher concentration of sodium chloride than the water. Are we following? Remember, concentration means that the quantity is stronger than the other one. Are we together? So, because this person is higher, has higher concentration, it will go. It will be preferentially discharged rather than OH because it is concentrated. And even if it was dilute, OH will go. So at the anode, remember this is negative ion, so it's going to be discharged at where? At the positive, which is what? Anode. So at the anode, what is going to happen? So at the anode, you have, so who is living here? Chlorine. So you have chlorine plus chlorine. That will give us what? Chlorine gas deposited at the anode. Are we together? So this has gone, this has gone. So what will be the resulting effects of the electrolysis? You have sodium and hydroxyl. Sodium hydroxyl is what? Is a base and is alkaline. So if you test what will be the pH of the resulting mixture after the electrolysis, it will be alkaline because sodium hydroxide is alkaline. Now, if you test it with litmus, it's going to change red litmus paper to blue. Are we following? Yeah. Let me give you one more. Okay, so let's look at dilute copper 2 chloride. Dilute copper 2 chloride. Let's see how it will be discharged. Okay, so let's disassociate. This will give us this. Then in water, it will also give us this. Now, between this and this, who is going to go at the cathode? Let's look at their electrochemical series. This person is higher than this in the electrochemical series. So who is going to go? The lesser person is going to go, right? And we look at the concentration. Is it concentrated? No. Are we following? We also look at the electrode too, because I told you there are certain factors that affect this. So is it concentrated? No, it's dilute. So that means between these two, who is going to go? Copper. Copper is going to go. Now copper is what? Positive ion. So it's going to be discharged at the negative, which is at the negative electrode, which is cathode. So at the cathode, what is the reaction that will take place there? Copper 2 oxide will be discharged. Are we following? Copper will be discharged there. Then at the anode, what happens at the anode? At the anode, this person and this person, who is going to be discharged? Looking at the electrochemical series, OH is going to be discharged. And again, it is dilute. So who is going to be discharged? OH. Since it is dilute. So you have OH minus plus OH. So you have OH plus OH will give us what? H2O plus what? Plus O. H2O plus O. So this O plus O will give us what? Oxygen gas. So oxygen will be deposited at the anode, copper will be deposited at the cathode. And then at the end of the day, what do you have left? Hydrogen and chlorine. So what will be the resulting effect of this solution? The resulting effect of this solution will be what? Acidic medium, because this is presence of hydrogen. Hydrogen and chlorine is what? Acidic medium. So which indicator are you going to use? If you use litmus paper, it will turn blue litmus paper to red. Are we together? So the nature of electrode also affects. So these are the factors that affect the preferential discharge of ions. Now we'll be moving over to the standard electrode potential. So quickly move over to the video right now to watch it. Thank you very much for watching. Bye.